Hello everyone, my name is Rishabh. My enrollment number is e20cse203. My batch is EB11. Today I am going to discuss about development of an automatic scheduler for multiprocessing under multi-core CPU. So let's start. Abstract. So multiprocessing is a way to increase the performance of computer by having multiple processors in one device. Multiple processors are used in applications such as digital signal processing, image processing, and video encoding. Multiprocessing can be divided into two main categories: symmetric and asymmetric multiprocessors. Symmetric means that each processor has exactly the same number of physical core, but asymmetric means that some processor have more core than others. Since both types of multi-threading involve several processes of working together on a task at once, they are also known as shared memory multiprocessing. The central theme here is that there needs to be a coordination between the processes running on these machines, several within organization network infrastructure, which bring us to the title of the topic, automatic scheduler for multiprocessing. Now, the introduction part. The problem is that there are many applications that requires the scheduling of job in order to run at a specific time. For example, a office worker may want to read email and write them on different days. At time when they have more time available, they would like to schedule their email according to personal preference. However, these requires them to manually check the schedule every day and make changes if necessary. In addition, there may be situation where multiple employees need access at the same time, emailing, but not necessarily at the same time reading. This can lead to frustration for the both worker as well as manager, who have little control over which employees get what job and task type during busy periods such as holidays and peak time such as weekends. The solution is automatic scheduler. Now, the multiprocessor scheduling. So, multiprocessing is a method of operating a computer system where several processors operate simultaneously. In multiprogramming, one task run at a time and unrelated tasks are executed concurrently. Multiprocessor systems may use either simultaneous or pipelined execution to achieve higher performance than that single processor system. Scheduling refers to the act of assigning available processor time in such a way as it minimize conflicts between threads or processes having different priorities. Scheduling can be performed manually by human operators or automatically by software agents running on system. Scheduling algorithms are based on various models that represents how threads should share resources such as memory space, file descriptors, and input-output channels. These model varies considerably depending on whether they are intended for threaded application with short execution time, or even heterogeneous one where multiple CPUs run concurrently at low level parallelism level, like MPI or OpenMP etc. Now, approach to multiple processor scheduling. There are three major scheduling approach: preemptive, non-preemptive, and cooperative. Preemptive, a process that is scheduled before other process is allowed to run. This can be done by using time-based or event-based model. For example, the OS scheduler. Non-preemptive, the process that does not preempt the other running process in order to complete its work prior to the starting other task. OS scheduler may use this type of model for multi-threading applications because it allows threads to run independently from each other at their own pace until they reach the endpoint where one thread must wait for other thread before continuing execution on its current task. Now, cooperative scheduling. The most common approach used by AI/ML system where multiple tasks shared resource such as memory buffer or space among themselves so that no one holds too much data at any given time. Instead, everyone gets equal access through their lifetime. Now, processor affinity. Processor affinity is the assignment of a processor to a particular core. Processor affinity can be static or dynamic depending on the situation. For example, if you have multiple core in your system, then one might be reserved for each core. This allows applications that require exclusive access of their own CPU cores to run their assigned resources without any other application being able to run at the same time. On another hand, if you are running multiple threads within a single process, for example, within a single process, for example, then the importance that they don't interfere with each other. This ensures operations and avoid potential issues caused by resources contentions among threads running in different cores CPUs simultaneously. Now, load balancing. Load balancing is a technique to distribute the workload evenly among multiple processors. Load balancing is used in multiple processor system where it can be achieved by distributing the task to different processor and assigning tasks to processor according to their speed. Load balancing has several advantages. First advantage is increasing system performance because each processor can execute their own specific task without interfering with other processor running on other processors. The overhead of load balancing is negligible compared with the using separate hardware for each processor. And the third is, if there is enough resources available, then you don't have to worry about bottleneck due to their own programs. Execution time constraint: when you run them inside your program's main loop, you just need some memory space and a couple of threads per core so that they don't interfere too much with each other's workflow. Okay, now the next part is multi-core processor. We will discuss the development of an automatic scheduler for multiprocessor. First, we need to understand what a multi-core processor is. A multi-core processor is a multiple CPU core that can run different program at the same time or even in parallel with each other. These core are independent processing unit IPUs, meaning they don't share any resources with each other like a memory or input output device, but they still may share some internal structure. The idea behind multiple IPUs was originally proposed by von Neumann in 1945 when he described his design for general purpose computer based on discrete transistors instead of vacuum tube, and relies as used in other computing device at that point of time. The first commercially availability of computer using such architecture was IBM's System 360 mainframe introduced in 1946. Today, desktop all use some variation of either Intel x86 or ADM x86 processor, which have 2 or 8 core per processor package. Now, the next topic is symmetric multiple processor. So, a symmetric multiple processor SMP is an architecture in which all processors are identical. It is a shared memory system where each processor has its own local memory but share the same address space with other processor. The first systematic multiprocessor SMP design was developed by IBM's Thomas Sterling, who was awarded in 1974 National Medal of Technologies for their work on this topic. Now the next topic is master slave process multiprocessor. So, master slave multiprocessor is a type of computer architecture where only one processor, called the master processor, has all the memories, and other processors are called slave and they do not have access to any memory on their own. These processors can only access data from the main memory available in their master's RAM, random access memory. The decision making process is performed by the master processor, which decide which program should run next based on its internal state or external input signal. It also executes instruction written by programmers using assembly language or high level language like C++, etc. Slave processors communicate with each other via a message passing mechanism where they send message containing data required for the execution of their respective task back to the main memory where it waits until it receives the acknowledgement from other slave indicating that its task has been completed successfully. Now, the next topic is visualization and threading. Visualization is a technique used to allow multiple operating systems to share same hardware. Visualization can be implemented in hardware or software. In hardware, it involves using specialized processor that simulates virtual machine on top of the processor. In software, visualization are created by running one operating system as through it where other, for example, Windows XP runs as if it were Windows 7. Visualization allows you to run multiple applications on single computer without having them conflict with each other or interfere with each other. Access to resource like memory and disk space. For example, if you have two computers set up so that one acts as your main workstation while other has all of its program installed onto it, including word processor documents and Excel, PowerPoints, etc. etc. Then when someone need to access their document file from both device simultaneously, they just open up WordPad from both the computer at once. It won't interfere or it won't create a deadlock. Now, the conclusion part. So, in this, we have discussed the development of an automatic scheduler for multiprocessing. We have shown that enough through it is difficult to find an optimal solution for this problem. There are several ways in which one can make progress towards obtaining such an optimal scheduler. In addition to our work on finding a good solution for this problem, other researchers have been able to working with multiprocessing scheduling algorithm and making improvements to them. These improvements includes or includes both algorithmically driven one as well as those based on any sort of empirical evidence such as experimental result. These type of study will help us further understand what makes a good scheduling algorithm, and how to best implement such system into practice in real world situation where real people may use them. So thank you for patiently listening to me. If you have any question, you can like find me on my email id e20cse203 bennett university.edu.in. Thank you so much.